I'm not supposed to take it off. They're gonna, if they walk by and they see me with it off, I get in trouble. So anyway, here we go. So there's the same vocabulary. Mono stands for one. Nomial, the word, the suffix nomial is what stands for term. Poly, many terms. So definition, a term, you have many types of terms. A term can either be a number by itself. If it is a number by itself, it's a special term called a constant, which we learned what that was first week of school. It could also be a variable. How do you identify a variable? How do you recognize a variable? It's just a what? It's just a letter. Now, the word product itself stands for doing what? It's a multiple of numbers with variables, a multiple of numbers and variables. So just like the example that we used in the little half sheet, say I take 3 and multiply x, 3 times x is what? 3x. Put them together, you get 3x. This is a term. It's a multiple of a number with a letter. You could also see it differently. You could see it with parentheses, 3 times x times y. And what does that give you? What's 3 times 3xy? And that's also a term. It's a multiple of numbers and variables, more than one variable. So in this chart, you also have other examples of things that are monomials, that's just one term, and examples that are not just one term, or examples that are not terms at all, or that are not a polynomial at all. So look at this first example here on the right side. Why is that one not a monomial? There's a plus sign creating how many terms? So this is a binomial. Why would this next example not be a polynomial? Variable on the bottom, not just because of the fraction, because there is a fraction in this example over here. It's the fact that there's a variable at the bottom. Now, this next example, 3y, that one is a monomial. So that one's more of a typo. So I'm going to write plus x minus 2. All right. If this was the original one, why would that one not be a monomial? How many terms? There's actually 3, making this one a trinomial. And the very last example, why can that one not be any type of polynomial? Variable at the bottom, once again. You cannot have a variable at the bottom. You cannot have a variable on the bottom of your fraction. You can have a fraction, just not a letter there. So a constant is a specific type of monomial that's a number and no letter, a number and no variable. Which example in the table shows you an example of a constant? Which one is an example of a constant? Look at that table. Which one is the number 10? You have a number, no letter attached to it, the number 10. Before we jump back to this one, if we have a sum of 2 monomials or a sum of 2 terms, binomial. Remember, bi is the prefix for 2. What about 3? Trinomial, tricycle. So if you have a monomial, a sum of monomials, plural, multiple terms, many terms, it would be a polynomial. Now, this doesn't only apply to the sum of them. What's the opposite of sum? The difference. What does it mean to take the difference of something? subtract. Opposite of adding is subtracting. So this applies to adding and subtracting. Okay, turn the page when you're ready, or flip it. You haven't folded it. So in this chart, they want us to write the specific name based on the amount of terms the example has. 3x squared, how many terms does that have? So that makes this a monomial. -9, how many terms? 1, but it's a very, and it is a monomial, but it's a very specific type of monomial called a what? Thank you. Monomial, it's called a constant because it is a number without a letter. What about 2x minus 7? How many terms do you have there? There's 2. Ruben, stop participating because you already went to Mr. Onyx. 2. It's separated with the minus sign. You have 1 term, 2 terms. This is a binomial. The next one usually tricks people. How many terms? Still also 2, because you still only have that 1 plus sign separating those terms. It's still a binomial. Pay attention to your plus and your minus signs. What about the next one? So it's a Reuben. I see you holding up fingers. I'm not stupid. Trinomial. And then the last one. I'm gonna chunk something at you. Trinomial. Okay, trinomial. Now, this set of rules, this 1, 2, 3 here, I don't exactly agree with it. I don't like this first one, so we're gonna get rid of it. And this is actually only 2 steps, okay? The first step when you're adding or subtracting these polynomials, when you're adding or subtracting 2 binomials, 2 trinomials, whatever it is, a binomial with a trinomial, first step is going to be to distribute. What does it mean to distribute? To multiply. And then we combine. What does it mean to combine? Add or subtract. Okay? Just like the steps that we use to simplify the laws of exponents, first you want to multiply if you can, and then you add or subtract. In this case, we're going to be multiplying to get rid of the parentheses. Now, the biggest difference with laws of exponents and adding and subtracting polynomials is that you're going to be adding or subtracting the coefficient. When we were working with laws of exponents, we talked about it over and over that the laws or the rules apply to the exponent. These rules apply to the coefficient. By the end of the week, you're going to have to know when to apply it to the coefficient and when to apply it to the exponent. Now, don't get scared because with the exponent part, most of the time it's only going to be an exponent of 2. All right, so let's look at example 1. We're going to distribute to get rid of the parentheses. Now, both of these binomials, because there's groups of 2 terms, they're being added. Notice we have a plus sign. We're going to add those together. But in order to add those together, I have to distribute first. There's no number in front of the parentheses, so what number do I put? A 1. Now, some of you may see it, some of you may not. When I multiply every single term by a positive 1, what happens? They do stay the same, but we are still going to distribute. We're still going to show that we're multiplying because tomorrow it won't stay the same. 1 times 4a is still 4a. 1 times -5 is still -5. 1 times -7a, -7a. 1 times 5 is 5. I've gotten rid of the parentheses. Tomorrow it'll be a little bit slightly different, but we're still going to distribute just to remain consistent. Now, what did we do with laws of exponents to help us So it wouldn't look so jumbled up. So you wouldn't be trying to confuse one with the other. When we combine, we want to what? Put them in groups. Let's put these in groups. So what can I group? What can I combine with 4a? Negative 7a. So right here, it's going to be important to point out to remember that the sign in front of the number is the one that belongs to it, not the one behind. The plus sign belongs to the 5, not the 7. The minus sign belongs to the 7. So we're going to take 4a minus 7a. And what does that give us? Negative 3a. We're only adding or subtracting the coefficient, the number in the front. Okay, let's try the next one. What can I group or what can I combine with negative 5? The positive 5. So negative 5 plus 5 will give me what? 0. So essentially this one does cancel out. And my answer is negative 3a. You may and you will have more than one term in your answers, but for this specific one, it's just negative 3a because the 5's canceled out, okay? Questions on this one? Today's lesson is pretty straightforward. It's pretty simple as long as you're able to group them correctly. All right, so let's put our ones in the front and we're going to distribute those ones to show that we're eliminating or getting rid of the parentheses. Now, I'm not going to jump ahead like this on tomorrow's lesson just because tomorrow that one will be affected in some way. This right now, it's just because we're adding, okay? So 1 times 9y is still 9y, 1 times negative 7x, still negative 7, and so forth. I'm just going to bring down all my terms, not going to change anything. I'm getting rid of the parentheses. There will be some kind of change tomorrow. I'm just going to keep repeating that. That way you don't forget. After you're done distributing, what do? Group them. What can I group or what can I combine with 9y? Negative 3y. And when we add those or subtract those, in this case, we're subtracting the coefficient. So 9 minus 3 gives us 6y. Negative 7x combines with positive 8x. So negative 7x plus 8x gives us what? 1x. 15a combines with negative 8a. So 15a minus 8a gives us what? 7a. Now, can I add 6, 1, and 7? No, they're not like terms. They cannot be added. So I'm just putting them together, 6y. It's a positive 1x, so plus 1x, positive 7a plus 7a. Now, on your assignment, if you can do without this step right here, that's fine. You can't, keep going. Ready? Questions? Look at the next example before I move on. What do you see? What is the big difference there? Now we're adding exponents into the mix. We're not going to do anything with the exponents. We're still going to keep the same energy, same process. Let's put the ones and distribute them, multiply them to eliminate the parentheses. Nothing is happening because we're multiplying a positive 1 on both groups of parentheses. So 3x squared plus 5xy minus 2y squared plus 4x squared. And I went ahead and put a 1 on that y squared. All right, let's group them. What can I group with 3x squared? Correct. Can I, it's good to point this out, but can I group 8xy with 4x squared? No, I can't, because this would be like, I like to use food just because that makes it more, I don't know, more familiar. But this would be like having a double cheeseburger with 2 meats. And this is like having a burger with bacon, something different, right? So I can't put those two together. You have to have the same letter to the same exponent. And if it has 2 letters, it has to have the same 2 letters to combine it. Now, just like we wrote in next to the steps, what am I actually adding? The coefficient. So if I'm adding the coefficient, I'm adding 3 plus 4 to give me 7x squared. Notice nothing happened to the exponent. In this rule or in this problem, the exponent does not change. Now, somebody had to visually see it, see the difference in order to get it. So don't write this part down that I'm about to put beside. I just want you to see it. 3x squared. When we did laws of exponents, there was no plus or minus sign. Here we're adding them. So we added the coefficient. With laws of exponents, we were multiplying them. So if we multiply 3 times 4, we get 12. If we're multiplying x squared times x squared, you add the exponent to give you x to the 4th. Big difference in adding and multiplying, okay? So don't confuse those rules. And we are going to learn how to use both of them in the same problem by the end of the week. All right, what can I combine with 5xy? Negative 8xy. So 5xy minus 8xy gives us negative 3xy. Negative 2y squared combines with, yep, y squared with 1y squared. So negative 2y squared minus 1y squared gives us what? Negative 1y squared. Now, can I combine any of those? No. They have to be the same letters with the same exponent, and neither of these match up. Minus 1y squared. Questions? Everybody get it? All right. Example 4. We have a rectangle. It has a certain length and a certain width. It wants us to find the expression for the perimeter of the rectangle. What is my key word? Perimeter. Perimeter. Now you might want to draw small, write small, because everybody's been complaining about the amount of space. It has a perimeter. Now length means that it's my long side. 10 plus 7r minus r squared. I always find it helpful to first draw it. That way I could visually see it. They also give me the width or the short side of negative 6r squared minus 18 plus 5r. What do I need to do? Because we're asking for the perimeter. Add both of these. Perimeter. What do you do to find the perimeter? Some people will say to multiply both sides. What are you doing when you're multiplying both sides? You're finding the area, but the perimeter asks us to add not 2 sides, we're adding what? All 4 sides. Now, in order to be able to add all 4 sides, I need a length and a width on all 4 sides. But because this is a rectangle, I do know that the top is the same as the bottom. So I'm going to go ahead and fill that in. And I know that the left is the same as the right. So I'm going to fill that one in as well. And then combine. Don't forget to fill in all your sides, and don't forget to read the question. Not all questions ask you for the perimeter. Not all of them ask you for the area. You have to be careful about that. Now, when you're combining these, it always helps to start with the one with the highest exponent. So I'm going to start with 6r squared. What can I combine or group with 6r squared? The other 6r squared. What else? You can't combine r squared with r, same letter and same exponent. Negative 1r squared right there. We have 2 negative 1r squares, okay? So I'm gonna write that over here, negative 6r squared minus 6r squared minus 1 minus 1. Now we're only adding or subtracting the coefficient. There's 4 numbers at once. This is where it gets it might get a little confusing, but I'm not gonna let it get to me because I have a calculator, right? Some people get confused on when do I use minus, when do I use negative? If you are that person, listen to this. You could do -6 plus treat everything as a negative and just do plus negative to give you -14. If you know the difference between a negative in the front, minus in the middle, you could do that as well. -6 minus 1 minus 1. There's your -14. What you never ever want to do is minus negative. Using a minus negative, look at the difference between all 3 of these. Minus negative will give you the wrong answer. So if you're going to treat them all as negatives, do plus negative. If you know the difference between having a negative in the front, minus in the middle, do that, but never use minus negative, okay? -14r squared. Next, what can I combine or group with 7r? $5R. I have a couple of 5Rs and a couple of 7Rs. All right, so 7R plus 7R plus 5R plus 5R. What does that get you? 24. Good. And last but not least, what can I combine with -18? The 10s. We have a couple of 10s and we have a couple of -18s. Minus in the middle, negative in the front. What does that get you? -16. 14r squared, positive 24 plus 24r minus 16. Questions on this one? All right, last example. Example 5 tells you to combine. Once again, what is the difference between the word combine and distribute? Combine tells us to add or subtract. Distribute tells us to what? Multiply. So here we're going to add or subtract. We're going to combine like terms. So what can I combine with 1/2 g squared? Can I combine, can I add a fraction with the whole number?
Yes.
Yeah. Can I do it in my head? Probably not. I can, but probably chances are I can't, but I'm not gonna let it get to me because I have a calculator to help me. A lot of you guys, you see fractions and problems that should be super easy, but you just skip them or you guess on them because you refuse to use your calculator. 1/2 plus 3 gives you 7/2. Next, what can I combine with -4/5 g? Nothing, so I'm gonna leave that there. And then last, what can I combine with 7/2? 1/4. Can I combine two fractions with a different denominator with a different number at the bottom? Ooh. Yes. And I'm not gonna let it get to me once again because I have a calculator. Let the calculator do the work. You should be able to do this in your head. Some people still can. From what, 5th or 6th grade? You get 15/4. But regardless, I have no excuse because I have my calculator. Remember, or I don't know if I've told you, maybe next year or so, I don't know. It was supposed to be started last year. They want to take the calculator away for the STAR test. So you might as well pass it right now while you can, while you're still allowed to use it, okay?